Hello and welcome to part 1 of the weapon trace tutorial. I hope you've seen the introduction. If not, there might be some things that are confusing. But regardless, I will be showing you a couple of things I have already set up that I won't be giving a tutorial on necessarily. In my third-person character on begin play, I spawn this sword actor and create a reference and attach it to a socket on my mesh. Said sword actor is a part of weapon base. This weapon base blueprint has no code. It just has a static mesh that has nothing changed except for the fact that it has no collision. The weapon that I turn that into is this static mesh of a sword. It has two sockets, that being the start and end. It is important that you name these correctly, the start and end, in a way that you can remember. Because we will be referencing the names of these specifically later on in this system. But the start is at the base and the end is at the tip of the sword, which is also important because we need to calculate our points from the bottom to the top, or in this case from the hand to the tip of the blade. And finally, I have this BP training pole, which is just a cylinder, a static mesh with nothing else changed about it and no code. And this will be a pole to test out the damage functions. And as I said, I won't be showing you how to apply damage. I will just show you when to do it, because applying damage is very specific per game. How exactly you want to calculate this and anything else that might come into play. So without further ado, I'm going to close the sword, the training pole, and the weapon base, and I will keep the third-person character open because we will need this later. Let's start by setting up the parameters for our trace. So inside of the content browser, I have a folder called weapon trace, and inside I will make a structure. Call this f_trace params. I will be adding 11 variables. Oops, that's 12. You can go. All right, the first one is start socket, which is a name. The next one is also a name, which is the end socket. The next is number of points, or I should say number of trace points, and this is an integer, and this is the number of points between our start and end sockets. Then there is use line trace, which is a boolean. We will usually be using a sphere trace because it is a bit larger and easier to hit with, but if you need to use a line trace, then you can with this boolean, and I would recommend you do so only for the enemies and not for the player, and I will get into that later why that is. That's more of a game design perspective rather than just good code. Next is the radius, which is a float, and this is the radius of our sphere trace. Next is the extend amount. In case you want to extend the range of your trace beyond the end socket, you can add an extend amount as a float. Next is the bounce percent and the sweet percent, which are both also floats, and these will determine the percentage at which we will make a bounce or a sweet spot hit. Then there is the trace slot, which is only used if you have multiple traces going at once. So if you have a character dual wielding a weapon, or perhaps you have a weapon that has multiple traces going at the same time, like a pair of scissors, or a twin blade or something of the sort, then this trace slot integer is going to determine which of the tracing components we are going to use, because this component can only trace once at a time. If we try doing multiple, then it will grab the data from one frame and apply it to a different mesh, which means it cannot exactly calculate the positions of two meshes at the same time. So instead of doing that, I just add another component to the character and use different slots, like these. Then there is the owner as weapon, which is a boolean. And this basically means that if you have something like a fist or a kick, then you need the owner of the animation instead of the weapon blueprint. And the final one is the debug type. In case you want to debug this, you can make it a draw debug trace enumeration. And this about does it for the trace parameters. So let's save this and close it. Now, back in the content browser, we still need a way to communicate the weapon mesh to our, or more specifically, the weapon blueprint to our tracing system. So let's go ahead and make a new, make a blueprint interface. Call this BPI underscore weapon trace. In here, we have a new function and call this get weapon BP. And as an output, we will have the weapon as a BP weapon base object reference. So let's compile and save this, and now we can close this. Oh no, wait, let's open it back up. I'm also going to add the apply damage, just for the time being. Okay, so now let's get into the meat of it. Let's make the actor component. So I need, whoops, that's not in here. It is a blueprint class of type actor component. Call this AC underscore weapon trace. Open this up. I'm going to remove event tick, and in the class defaults say start with tick enabled to false, because we don't need to tick the component, because it will use the ticking event from an animation notify state. So let's compile and save this. And let's see, I'm just going to make the functions first and then code them all later. I think that would be best in this situation. So let's start with the big one called melee trace. And this will, oops, not here. I need some inputs for the trace parameters, which is the trace params that we made earlier. And we also need the weapon, which will be a scene component. As an object reference. Let's make, and that does it for the melee trace function. Let's add a new function, and this is called, I need to check my notes again, get socket locations, which will turn the sockets for the start and end into vectors, which means we need the start socket as a name, end socket as a name, and the weapon as a scene component. The next function we need is to calculate trace points with inputs for the start location. Oh, whoops, which reminds me we need outputs for this one, which are the start location vector, whoops, vector, end location vector. And this will become the same ones that we plug into here. So we make the start location, end location And in order to calculate the locations in between, we also need the number of trace points, which is that integer that was a part of the trace parameters structure that we made. And this one has an output for trace points, which is a, whoops, I did it again, which is a vector array. And these would be all of the points in between our mesh. So not per se the ones that it stores for each frame, just the points that it will calculate in between the mesh. Now then, both of these two functions will be integrated into the next function, which is called set current trace points. Not current, just set trace points. And this will have the inputs that were required for all of the others. So we have the start socket, which doesn't have to be an array, just a single name. Then we have the end socket name and the number of trace points integer, as these were required by both of these. And we output the last frame points, which is an array of vectors, and this frame points. And finally, we have the function called draw traces. And this function is going to have mostly the data we need for a sphere trace or line trace if we need that. So this has start, which is a location or a vector, and we also need an input for the object types, because we are going to trace by object types and not by channel. If you prefer to do it by channel, you could, but I always prefer object type for this sort of thing, so you can differentiate between static meshes, vehicles, and characters, that sort of stuff, more easily. So this would be an eObject type query, which is the one that appears for a sphere trace, and make this an array. And let's see, what other inputs do we need? We need the radius. Oh, that's not how you spell it. Radius, which is a float. We need, first let's do the ignore actors, which is an actor object reference array, which are the actors to ignore, which is usually self and owner, and maybe the weapon of the owner as well. What else do we need? We need trace color. This one is mostly just cosmetic, but it's very useful in case you are debugging this. We need use line trace, which is the boolean we had, and we need debug type, which is the debug type. What was it? The edebug type denim, was it? No, it wasn't this one. I have to open this. Draw debug type, that was it. Draw debug trace. And the outputs are for hit results, which are hit results this array. I could call this hits. And another output for, let's just call this return. No, wait, let's just make this a space so it's empty. And a boolean single. That looks weird, never mind. Return value. Try this, that's better. So that'll about do it for the setup of this system and for part 1 of this tutorial series. So I know this one was kind of boring, but that's alright because we need to do this kind of setup before we can do anything else. And this just means we have the boring part out of the way. So I hope you will join me for the next part where we will be programming all of these functions to contain the logic that we need to draw traces. So anyway, that'll be all from me for today, and good luck.